Okay, so we're doing number 8. A researcher claims that the number of cups of coffee US adults drink per day is as distributed in that graph. So we wanted to check on that. So we select 1,600 US adults and ask them how many cups of coffee they drink per day. The table shows the results at alpha equal 5% test the claim. Remember, guys, this is called the observed values here. The survey results are the observed values. So before even we write anything down, guys, let's get stuff ready for the calculator. So let's put the observed values in L1. So what I like, you guys, you see those frequencies, 570, 432, 282, put them in L1, and I'm gonna do the same. So we got 570, we got 432, we got 282, we got 152, and 164. Now for L2, we need the expected values. Can someone tell me how we're gonna do the expected value for 0 cups? So we go to L2. What goes for next to 570? Feel free, guys, to give your input. So how do I compute the expected values? Okay, we have 36% 0 cups, guys. So 0 cups, 36%. So you do 36% times 1,600. And let me show you here. 36% times 1,600. So you just do 0.36 times 1,600. And for the next one, 1 cup, 26%. So guys, do 0.26 times 1,600. And put it in L2. The next one is 2 cups, 19%, which is 0.19 times 1,600. It was easier in the previous exercise. It was 1,000, so it was easy for us to compute it, but now it's 1,600. This is where I got the 1,600 from. It's right here. 3 cups, guys, 8%. So do 0.08 times 1,600. And I'll show you my calculator screen in a second. And the last one, guys, is 11%. So if I share the screen with you, these are the observed values. These are the expected values. And the last one, guys, was the 0.11 times 1,600. This one was 0.08 times 1,600. So it's the percent times total, percent times total, percent times total, percent times total, and so on and so forth. And now let's write down the null and the alternative hypothesis for this question. It's number 8. So HO, distribution of coffee drinkers is as claimed. And he's asking us to check if this distribution is still valid. So the claim is right there. Distribution has changed, if you like, or not as claimed. Now, probably a question you want to ask me, when do you put the claim in HA? If he asks you, has the distribution changed, or it is different from the claim distribution, then the claim will be in HA. So we put the observed values in L1, we put the expected values in L2, and then we run a chi-square goodness of fit test. And let's run the test, guys, now. When you do your homework online, guys, and you need help on how to find the test statistic, it's gonna show you the steps just like I did it by hand. But feel free, guys, to put your observed values in L1, expected values in L2, and run the GOF test. It's gonna give you the results. So it is right there. You see L1, L2. How many categories I have? I think we had 5 categories, so it is 4, still 4 here. And you want a draw? I can do a draw here for you. See the p-value? Okay, so chi-square is 7.588. You can see, guys. And you need the p-value. 0.1079. Yes, any questions?
Can you repeat what you said about HO and HA, like when the distribution would, or when the claim HA?
So HO should be distribution is as claimed, and HA should be always distribution is not as claimed, has changed or is not as claimed. Now, if he asks you to test that the distribution is still the same, then your claim will be an HO. If he asks you to test that the distribution has changed, then your claim will be an HA. That's what I was trying to say. Okay. And the p-value, I don't remember what was alpha, guys, in the question. I think it was 5%. Let me double check. Okay, alpha is 5%. So we'll go back. Okay. Well, you guys agree with me that this is bigger than alpha. And if you fail to reject HO, and then there is not enough evidence to, you can say to reject the claim or to conclude that the distribution has changed. There's not enough evidence at the 0.05 level of significance to reject the claim distribution. We cannot reject it. When you cannot reject something, that means this something that could be still accurate, still be good. Okay. So this is it for section 10.1. I'll do one more exercise on Wednesday. I'll do another, probably couple more on Wednesday, and then I'll quickly do section 10.2. So, and then we'll spend, just the rest of time talking about the test next week.